The topic which we are going to discuss is recent advances in dental waxes. To begin with, conventionally, wax patterns were fabricated with wax and waxing instruments, for example, the most popular PKT instruments. Wax is used to make the patterns because it can be conveniently manipulated, precisely shaped, and can also be completely eliminated from the mold by heating. The fabrication of the wax pattern is the most critical and labor-intensive step in making the porcelain-fused metal crown. In this time-consuming task, the wax up's quality is dependent on the skilled labor of the individual. Because of the wax pattern's color and glossy surface, small defects can be difficult to identify. Zestler et al. Found the act of removing a wax pattern from a die with a shoulder margin causes an average of 35 micrometer opening of the margin before investing. Wax has several inherent limitations, namely delicacy, thermal sensitivity, elastic memory, and a high coefficient of thermal expansion. Today, by introducing different CAD/CAM systems, it is possible to fabricate the wax patterns made from castable materials and omit several limitations of conventional wax-up technique. Using CAD/CAM systems have many advantages such as producing higher and more uniform quality restorations by using commercially formed blocks of material, standardizing restoration shaping processes, and reducing production cost, labor, as well as time. Another advantage is the potential to enhance accuracy as they omit several fabrication steps used for waxing, investing, and casting. CAD/CAM systems also have some disadvantages. The scanning systems have the limitation of finite resolution, which can result in edges that are slightly rounded. The point clouds obtained in scanning are transformed through a CAD software system algorithm into a smooth and continuous surface, which can also lead to some internal inaccuracies. This can lead to interfering contacts at the incisal or occlusal edges and can be detrimental if they occur at the margins. Although CAD/CAM technology has already changed dentistry, it needs some improvement in scanning procedure, data processing, manufacturing techniques, and material processing to be a competitive alternative for conventional method of fabrications. Now, milling wax. Milling waxes are specially formulated to meet the particular challenges of machine processing. The ideal hardness of the wax patterns prevents shaving from adhering to the wax up and clogging of the milling tool so that the view of the milled surface is unobstructed at all times. The gray milling wax is also formulated with the maximum possible opacity, thus enabling optimum visual assessment of the milled surfaces and contours. The ideal motor speed for milling wax is approximately 2000 to 5000 rpm, depending on the blade geometry and diameter of the milling tool used. Solidification temperature of both milling wax versions is approximately 62 degrees Celsius. Availability is in green and gray color. Crown wax. Hard and medium hard waxes, compositions in blue, dark blue, gray and dentine ensure optimum waxing of all type of crowns. Color preferences and specific customized contouring can be easily provided by three shades. The balancing shrinkage of crown and bridge waxes is reduced to a minimum by a selective use of high quality raw materials and rigorous production management. Crown wax is particularly suitable for waxing up with either an open flame or an electric wax knife. Thank you.